Assalamualaikum and very good morning. My name is Nur Hidayah binti Sharizan. I'm studying in program UR65230008, Electronic Telecommunication Design. My matric number is 20139158. Today, I would like to discuss about my mini project. My mini project title is to design and analyze of AM receiver circuit. In this mini project, I will use amplitude modulation and demodulation circuit. Then, I will explain how amplitude modulation and demodulation circuit can be an AM receiver. First of all, I want to explain what is amplitude modulation, demodulation, and AM receiver. Amplitude modulation is a process by which the wave signal is transmitted by modulating the amplitude of the signal. It is often called as AM and is commonly used in transmitting a piece of information through a radio carrier wave. Amplitude modulation is mostly used in the form of electronic communication. Amplitude modulation is when the amplitude of the carrier wave is changed but phase and frequency as constant. Demodulation is a process of extracting an original message signal from the modulated carrier wave. A demodulator is an electronic circuit that is mainly used to recover the information content from the modulated carrier wave. AM receiver receive AM wave and demodulate it by using the envelope detector. An AM receiver circuit is super heterodyne receiver. This is the block diagram of super heterodyne receiver. If you can see, there are 6 elements that consist in this block diagram. There are RF amplifier, local oscillator, mixer, IF amplifier, demodulator, and audio amplifier. For this mini project, I will apply this block diagram into the amplitude modulation and demodulation circuit. Next, I will explain for each component that consists in this block diagram. First is RF amplifier. The antenna pick up the weak radio signal and feed it to the RF amplifier. RF amplifier also known as low noise amplifier. RF amplifier provides some initial gain and selectivity. RF amplifier minimize oscillator radiation. Bipolar and FET can be used as RF amplifier. Next, mixer and local oscillator. The output of the RF amplifier is applied to the input of the mixer. Then, the mixer receives an input from the local oscillator. The mixer will make these two signals. Output from mixer will be two frequency components, which is the sum and the difference of this signal. The output from mixer, also called as intermediate frequency. The local oscillator is made tunable so that its frequency can be adjusted over a relatively wide range. Next component is IF amplifier. The output from the mixer called IF signal. The different frequency between RF amplifier and local oscillator frequency. The signal amplified by one or more amplifier stage. Then we have demodulator. This stage is recover the original modulating information. The demodulator may be diode detector for AM. The output from demodulator will feed to the audio amplifier. Last component is audio amplifier. Amplify the audio signal then pass to the speaker. Objective for this mini project is to design amplitude modulation and demodulation circuit and to analyze the AM receiver that apply into amplitude modulation and demodulation circuit. The component and equipment that I use in this mini project is resistor, capacitor, variable inductor, transistor 2N, 2A, function generator, oscilloscope, and spectrum analyzer. So, as you can see, this is the circuit of amplitude modulation and demodulation. At the right side, we have the data input for resistor, capacitor, variable inductor, and function generator. We use oscilloscope and spectrum analyzer to get the result. Next, I want to explain about each part of circuit that related to the block diagram of AM receiver. First, RF amplifier. Based on the block diagram of the AM receiver, I know that at this stage is RF amplifier. It shows that at this stage, the amplitude was amplified from the data given. The input amplitude is 10 Vp. After amplify, the amplitude become 20 Vp. Next, we go to local oscillator. Based on block diagram of AM receiver, I know that at this stage is local oscillator. In this stage, input of local oscillator will feed to the mixer. Then we go to mixer. Based on block diagram of AM receiver, I know at this stage is mixer. Mixer is the combination of RF amplifier and local oscillator signal. This signal will feed to IF amplifier. After mixer, we go to IF amplifier. Based on block diagram of AM receiver, I know at this stage is IF amplifier. IF amplifier we identify using spectrum analyzer. After that, this signal will feed to the demodulator. Lastly, we go to demodulator. Based on block diagram of AM receiver, I know at this stage is demodulator. In this stage, the signal output from IF amplifier will be demodulated to the original signal. After the signal has been demodulated, the signal will feed to the audio amplifier, then will feed to the speaker. This is the overall result for my mini project. I will define this waveform by color and block diagram of AM receiver. The blue color is carrier signal and also known as RF amplifier. The pink color is message signal and also known as local oscillator. The red color is modulating signal and also known as mixer. And the last one is the green color is demodulating signal and also known as demodulator. Next, IF amplifier we will get on spectrum analyzer. In this spectrum analyzer, I get upper sideband is 104.959 kHz and lower sideband is 95.041 kHz. At the end of this mini project, I know how to design amplitude modulation and demodulation circuit. Next, I had analyzed that the AM receiver can be applied in amplitude modulation and demodulation circuit. This can be shown at circuit analysis section. I had described each part in block diagram of AM receiver that related to the amplitude modulation and demodulation circuit. In conclusion, I had learned that the AM receiver can be applied in amplitude modulation and demodulation circuit. Next, I also know that the amplitude modulation and demodulation circuit is one of the AM receiver. Then, I also realized that the block diagram of AM receiver is same like block diagram of amplitude modulation. That's all from me about my mini project. I want to thank for my lecturer for teaching me about this subject, and also thank you for watching my video.